In today's video, we are going to talk about the tricellular model. If you study one of the following exam, this video might be helpful to you. Let's start with the concept of the angle of sun. So the angle of sun affects the insolation intensity and amount received by the Earth's surface. So if we have high angle of sun, the intensity would be stronger over a smaller concentrated area. And the opposite, low angle of sun, the intensity of insolation would be weaker, but at a more dispersed location. So I have a small planet Earth and the flashlight stimulating the sunlight. So if you see the lower memo paper, and if we have the flashlight and the planet Earth at around this angle, we can see that the small memo paper actually receive quite bright of the flashlight. So the intensity of insolation is high at low latitude, high angle of sun, around 90 degrees. If you take a look at the top memo paper, you can see the light actually is not that strong. At high latitude region, the intensity of insolation is weaker over a more dispersed location. Okay, so now from the experiment, we know that higher angle of sun, intensity of insolation is stronger, and lower angle of sun, intensity of insolation is weaker. So it applies to low latitude region. At around the tropical region and equatorial region, high angle of sun and high intensity of insolation means that the temperature is higher. That's why if you go to the tropical region or equatorial region, you can expect a relatively high temperature. In the high latitude region with smaller angle of sun, insolation is weaker, we have lower temperature. That's why in the North Pole and South Pole, we expect relatively low temperature. Let's talk about the tricellular model. And three basic concepts. The first one is that insolation affects air temperature. The second one is air temperature affects air pressure. Air pressure affects air movement, that is wind. What is air pressure? Air pressure is the amount of air particles above the surface. More air particles, we expect higher air pressure, just like people, right? So if you have more people huddling together, we have higher pressure. Or if you have more homework, you get more pressure. So same thing, the more air particles, the higher the air pressure. Near the ground surface, with greater gravitational pull, we get higher air pressure. On the opposite, the amount of air particle higher in the sky would be lower. And that's why we have lower air pressure high in the atmosphere. And you can imagine each air particle is like one hot pack, the hot pack that you use in wintertime. So near the ground surface with so many air particles, it's kind of like sticking 100 hot pack on the body. So you feel very warm, right? But in the high atmosphere, high up in the sky, with less air particle, it's kind of like you only have 5 hot pack. So the temperature would be lower, right? What happened to temperature affecting air pressure? So when we have higher temperature, the air pressure decreases. Why hot air balloon goes up in the sky? Is because when we hit the air particle inside the balloon, it expands and become less dense and lighter relative to the surrounding colder, heavier, and denser air, bringing the hot air balloon up to the sky. Higher temperature, air particle heats up, expand, and become less dense and lighter. So they go up into the sky. Okay. As a result, we have less air particle near the ground surface. So less air particle means less air pressure. Now, let's talk about the influence of airflow on air pressure. When convergence of air particle, we have high pressure, just like we mentioned. More people, more pressure. More homework, more pressure, right? So divergence of air particle moving away, we have lower pressure, okay, because air particle move away. So now, if we factor in vertical air motion, now we are saying convergence actually would result in low pressure. So if we have convergence of air, so more air particle congregating, air particle pushing, keep pushing together, and the air particle cannot go underground, right? So the only way is for the air particle to go up to the sky, kind of converge, going up. So when we have air particle going up from the ground to the sky, we have less air particle near the ground. We have lower pressure. If we have divergence, what happens is when we have sinking air, we have high pressure because more air particles are congregating near the ground surface. So sinking air and divergence result in high pressure. So let's talk about the tricellular model. We have the Hadley cell, the Faro cell, and the polar cell. At low latitude region, the angle of sun is high, so air temperature is high. With the air particle being heated up by the sun, so they become hot air rises, resulting in low pressure. Because of rising air, we have less air particle, so low pressure. Because the temperature is lower with less air particle in the atmosphere, the air particle eventually cools and contract, becoming denser and heavier. Again, because we have the atmosphere, so the air particle cannot escape to the outer space. Eventually, they have to move away, rising warm air, pushing the air particle away. The air particle become cooler, heavier, and denser. Eventually, they sink. At around 30 degrees north and south, we have high pressure. So equatorial low pressure, because of rising air, high angle of sun, high temperature, we have the equatorial low. And we have the sinking air at around 30 degrees north and south. That's caused the subtropical high. We have a circulation of air from equatorial low, rising warm air, and then cool air at the high atmosphere eventually sink back to 30 degrees north and south, and air move from high pressure to low pressure. The relatively colder air from 30 degrees north and south will go back to 0 degree to replace the rising warm air, and that is the Hadley cell. Now, let's talk about the polar cell and Faro cell together. Low angle of sun result in weaker insulation. Low temperature means we have sinking air because air is cold and heavy, so they sink. Sinking air result in polar high pressure. At 90 degrees north, let's say North Pole, we have low angle of sun, so sinking air, high pressure, right? Because a lot of air particle going to the ground. So high pressure. And because the air particle cannot penetrate through the ground, they have to go somewhere. So divergence of air near the ground surface. Subpolar low actually is subpolar low pressure at around 60 degrees north and south. When we have the sinking air from 90 degrees north, high pressure, they travel further down to a low latitude region, 30 degrees north, we have relatively warmer air from the equatorial region, also traveling north around 60 degrees here. So when the cold air mass from the 90 degree meets the relatively warm air mass from the 30 degree subtropical region, the cold air mass is colder, heavier, denser. It is going to displace the warmer, lighter, and less dense warm air mass. The warm air mass will go up because the warm air mass get undercut by the cold air mass, and they keep going to 90 degree, and this is called the polar front. Because we have rising air, we have low pressure. So that's why we have subpolar low pressure at around 60 degrees north and south. Now let's do a quick summary putting everything together. At low latitude, 0 degree, with high angle of sun, the air particle heats up, expand, become less dense and lighter. So rising warm air result in equatorial low pressure. Eventually, the warm air in the atmosphere cools and contracts, and they become relatively colder, and they sink to the ground at around 30 degrees north, resulting in subtropical high pressure. And some of the air goes to 60 degrees north, and some of them go back to 0 degree to replace the rising warm and even hot air. At high latitude, around 90 degree, because of low angle of sun, we have cold sinking air resulting in polar high pressure, and some of them will travel down to the lower latitude to 60 degrees north when the relatively warm air mass from 30 degrees north meets the cold air mass from 90 degrees north. The warm air mass get displaced by the cold air mass and rising. That's why we have low pressure at around 60 degrees north, and some of them travel back to 30 degrees north. So that briefly explains how the tricellular model is formed. If you have any question, you can leave in the comment below. Thanks for watching. Bye bye.